In the last video, I was showing my IDE interface to my CF card and just starting to access that device, and that was working okay. One of the things in that video, and kind of as I was working through it, that was a little bit not the way I wanted it ideally, was just kind of the order of some of the bits and how I access those registers. And up on my YouTube video that I posted, I also had a similar comment from PVC, just maybe swap some of the orders of those pins around or those bits around. That might be helpful. And so I did go ahead and do that, and I thought I would just talk through that and maybe take a look at the changes in code and what the result is for that. So just a quick video here, and nothing too exciting other than making some changes to how I'm addressing the registers, and I'll just show some of the code that I've got that goes with that. So what you're seeing on the screen is, this table to the right is the kind of the standard pinout for the IDE. And you're going to see that there are 5 different signals used to select which registers you're going to work with. And there is a DA0, DA1, DA2, along with a chip select 1 and a chip select 3. And between those 5, that's how I tell the IDE device which register I want to write to or read from. And some of those registers, like one of the registers is to actually read data. So if I want to read or write data, I'll go to one of those registers to read and write. And this is how I had the actual setup before. And I had set up A5, 4, and 3 to connect to this 2, 1, and 0 respectively. And I had some logic to control this chip select 1, and I, for now, was pretty much just setting chip select 2 to high and not worrying about that so much. I needed some work yet to do on that. But I made some changes, and the changes I made are reflected over here. And if I go up, you're going to see now that I have A3 from my ISA-bus going into this DA2. I have A2, A1 going into DA1 and DA0. And then I have some logic in place for the 2 chip selects. And what I do with the chip selects is I cut it down to only use a single bit of the register address and not have to waste 2 because I'm not finding any cases where I need to have both of these active. It's either one or the other, so I could simply use a single address bit and an inverter to control one or the other. And that's kind of what I've done in this. But maybe what I'll do is real quick just show you what this looks like in code for a second. Before, this is the old way I was doing it. I have this register, and I set, first of all, 2 of the bits based on jumpers on the card. Gave me some flexibility to choose what base address the I/O is going to use. And then I had 3 bits that were address lines coming in, 2 bits that were those chip select lines, and then I always left this last bit 0 to keep with an even register address. And that gave me addresses that looked like this to the right: 44, 4C, 54, 5C. And then when I got down to this alternate register, it jumped back to 42 to 4A, kind of interleaved with these addresses before. And that's something I didn't like before and was thinking I needed to change that. And after getting feedback on that, I thought, well, let's just change that real quick. And so what I did is I took these chip select lines, those signals, and put them before the address. And what that results in is something that looks like this, where now I have 3 pins available for base address. So I have 3 jumpers, and I'm going to use 0, 1, 0 for now. And that gets me into this 4, 0 range. 4, 0 through 5F will be the entire range. And then I have basically, after that, 4 bits to select the rest of the register information. And what I've done is I have this 4th bit from the left. So 3 are set with jumpers. The next one is going to basically dictate which of the chip selects is active low. And then I've got 3 for those address lines, and then I'm always going to end up with a 0. And I did go back and validate that I do need to, at least for my design, I need to keep this last bit at a 0 and keep evens. And that's just due to how the 286 transfers data. If it's an odd address, it puts it on the upper byte of the address bus. And if it's an even, it puts it on the lower byte of the address bus. And I don't have circuitry on my IDE interface to actually move high bytes to low bytes and things like that. So I'm just going to stick with even addresses, and that'll always make sure that when I write to it, I'm going to write to the low byte of the address bus, which is what I'm looking for. Or if it's a 16-bit, it'll transfer the high and the low properly. So this is the setup I'm using. I did free up a bit when I cut it down to only use a single bit for the chip select, which means I get one more bit available in my configuration, and it allows me to cut the range down. So the range previously went from 40 through 7F. Now I'm using 40 through 5F for all my IDE registers. On the schematic, if I look at that real quick, again, I've got my A3 to 1, and then for the logic for these chip selects, I've just come down here and basically say, well, if the device is enabled, in other words, I'm in the right address range, and A4 is a 0, then make chip select 1 active low. If A4 is 1, then make CS3 chip select active low. And that's basically just saying that A4 is going to control whether I'm on the primary set of registers or the alternate set of registers. And I had to do some other, cutting and just running the right lines to get all this logic set up to move those pins around. But I did that, and front of the card doesn't look any different. But then if I get to the back of the card, it's a little bit messier than it was before. No worries, this is just a dev card, so my goal next would be to order a version of this, and I have some smaller CF card adapters en route that are actually less expensive and only have the 40 pin. They don't have this 44 pin, and I'm also going to orient them 180 degrees from where they are. Right now, if this is in the system, it's difficult to pop out that card and put something in. I want to be able to have this in and pull the card from the top, so I'll flip those around. But I think I'm getting pretty close to getting that. Once I get those in place, I probably will actually put appropriate mounting holes for those. Right now, the way I've done this is this just clicks in here, just into the pin header directly, and I put standoffs, but I don't actually fix those standoffs down. So now I will have those matching holes or appropriate holes over here, so that goes onto the pin header and is physically attached. Although this is plenty secure, I'm not too concerned with the current setup. So with this, then maybe I can plug it into my system, and I will pull up my serial output monitor and go ahead and turn on the system. Goes through its normal initialization, and then I do a little bit of a delay. And then I go through and I read that CF card. And the first thing I do is I read the status, and I'm looking for the status. The first bit of this status on the left has to come back as a 0. If it comes back as a 1, the card is not ready. So I put a loop here, and it only went one cycle where it wasn't ready. Then on the next loop through, it said, yep, I'm ready. Second bit has to be a 1. Once those two bits are a 0, 1, then the card's ready to go. And then I read out the IDE device information and print it in ASCII, then I print it in hex, and then I read out some specific values for my cylinders, heads, etc. And then I come down here and I read out some actual data. Before it, I also do a device reset, and that goes through that same process that you saw up above. But in my code, I can just show you what that looks like. I have a separate file for all my disk code, and I'm in this identify drive, and in the identify drive I do put in a delay. I probably don't need this anymore, but when I was initially setting this up, I put in a delay. I called the reset routine that I wrote to reset the device, and then I call a delay, and then from there I move into actually saying, okay, this is how I want to go out and pull back or send a command to it, and the command that I want to send to it is identify drive. So I send this command of EC, and I output that to the command register on the IDE device. And then after that, I come back and I really just fill in a buffer. And so I fill in this buffer here. I come in from my IO, reading from that register, put it into a buffer. and then I turn around and I write that stuff out. And first here is where I'm actually grabbing specific parts of that buffer and putting them into variables, but then I print the buffer, which is an ASCII print, then I print it in hex, and then I have this other routine that prints just specific drive info, and that is this part here where I'm just printing specific information. Now if I go down, I have this reset, and the reset, I've got some comments that once I tie this into my interrupt handler for disk services, I'll be setting it up accordingly, but at least for now, I've just come in here and said, okay, let's do a soft reset on the bus, basically a software reset on the bus. So I send a 4 to the command, then I send a 0 to the command, and then I check the status. I just need some delays here. And then this is where it's checking to see that those first 2 bits are a 0, 1, and if not, then I jump back up and repeat this loop until those bits are not, improperly set, until they are the values that I expect them to be. And in the middle, I'm just calling out the value of that register to my serial so that I can just kind of see what's going on. Those would be these lines where I see the first 2 bits is all I care about, but there, and these 2 down here. So those are the routines I've got to reset the disk, and then the routine that I have to identify the drive and fill in some variables with the drive data that I care about. And then when it comes to reading, all I have so far in this code is basically I call a reset, and if I get through the reset, then I go out and I say, well, which drive head, which how many sectors do I want to pull back? What sector number do I want to start with, and then what is my cylinder low and high value, and then I want to do a read with a retry, and then I go in and I basically read that, put it into a buffer, and then at the end of that I print out that buffer. And right now I'm not even worried about where I'm reading data. I'm just basically trying to say, okay, start at, in this case, this is device 0 or drive 0, which is this A0. And I want to read 1 sector, and I'm basically going to start with sector 1, and then I just kind of randomly picked a spot that isn't too high of an address for what specific cylinder do I want to go to. So I'm putting 0 in for the high, and I'm putting in a 110 binary for the low. And then I say read it, and off it goes. So that's really the code I have at this point. And like I said, the main part of this video is just to show I've maybe rearranged these pins or bit order a bit. It feels a little bit better. It's more logically contiguous here. So I go from 40 to 4E. My alternates will be in this 50 to 5E range. And that all is good at this point. So that's all I had. I need to continue then again finishing out that read procedure and trying to get to the kernel loading. But I just wanted to share some quick adjustments I made, and looking for any other suggestions or feedback any of you might have.